Hello children, welcome to math part. Today we are going to do second part of exercise 22B and we are going to start with question number 11 now today. So children, if you like the video, please share with your friends, and if you are new to the channel, please subscribe. We are given tan A plus cot A is equal to 5. Find the value of tan square A plus cot square A. This is again easy. What we will do is we'll just square both sides of this. So tan A plus cot A the whole square is equal to 5 square. A plus B the whole square is A square, that is tan square A, plus B square, which is cot square A, plus 2AB, that is 2 tan A cot A, is equal to 5 square, which is 25. Now, tan and cot are reciprocals of each other. So, we have tan A into cot A is equal to 1. So, this is how we get tan square A plus cot square A plus 2 times 1 is 2 is equal to 25. So, this 2 moves there. Tan square A plus cot square A is equal to 25 minus 2, which is 23. Got it? Given 4 sine theta is equal to 3 cos theta, find the value of sine theta, cos theta, cot square theta minus cosec square theta, 4 cos square theta minus 3 sine square theta plus 2. So here you are given 4 sine theta is equal to 3 cos theta. So what we can do is we can bring this 4 over here. So we get here sine theta upon cos theta is equal to 3 by 4. We just rearrange the terms. And sine theta upon cos theta is tan theta. So we get tan theta is equal to 3 by 4. So let us draw a right triangle where theta is an acute angle. So tan theta is opposite upon adjacent. So this becomes 3x and this is 4x. So by Pythagoras theorem, we get this as 5x. Now we are asked to find sine theta. So the first part, that is sine theta. Sine theta is opposite by hypotenuse. So opposite is 3x and hypotenuse is 5x. So 3x upon 5x, which is 3 upon 5. Then second is cos theta. Cos theta is adjacent upon hypotenuse, which is 4 upon 5. And then we are asked to find cot square theta minus cosec square theta. So cot theta is the reciprocal of tan theta. So we have cot theta is equal to 4 by 3. And cosec theta is reciprocal of sine theta. So we have cosec theta. Cosec theta is equal to 5 by 3. Now let us find this cot square theta minus cosec square theta. So we'll do the third part over here. So it is cot square theta, that is 4 upon 3 and then the square of that, minus cosec square theta, that is 5 by 3 and then the square of that. 4 square is 16, 3 square is 9, minus 5 square is 25, 3 square is 9. 16 minus 25 is minus 9 upon 9, which is minus 1. So this is how we got this as minus 1. Now the fourth part, you are asked to find 4 cos square theta. So 4 cos theta is 4 by 5. So 4 upon 5 and then the square of that. Minus 3 sine square theta. Sine square theta is 3 by 5. So square of that plus 2. 4 into 16, it is 64 upon 5 square is 25 minus 3 square is 9. 9 threes are 27. So 27 upon 25 plus 2 upon 1, which can be written as we can take the LCM 25 and 25. So which we get it as 64 minus 27 plus 25. Okay. 25 twos are 50. So we have 64 minus 27 plus 50 upon 25. So which we get it as 50 minus 27 is 23, and 23 plus 64 is 87. So we get this as 87 upon 25, which is 25 threes are 75. 25 threes are 75. 75 plus what gives 87. So we have 12. 75 plus 12 gives 87. This is how we get this as 312 upon 25. Question number 13. If 17 cos theta is equal to 15, find the value of tan theta plus 2 sec theta. So cos theta is equal to 15 upon 17. So let us draw a right triangle where theta is an acute angle. So cos theta is adjacent upon hypotenuse. So this will take as 15x. This is as 17x. Then we will be finding the other side. So 17 square, this particular side is 17 square minus 15 square, which is 289 minus, this is going to be the square root of, so 289 minus 225. So 289 minus 225, 9 minus 4, 8 minus 2 is 6, it is 64. So root of 64 is 8, so this we get it as 8x. Okay, now let us find tan theta. So we have tan theta is equal to opposite upon adjacent, so which is 8 upon 15. And sec theta is reciprocal of cos theta, so it is going to be 17 upon 15. So let us find tan theta plus 2 sec theta. So let us substitute the values. 8 upon 15 plus 2 times 17 upon 15. So which is 8 plus 7 2s are 34 upon 15. 8 plus 34 is 42 by 15. 42 by 15 is divisible by 3. So 3 14s are and 3 5s are. So where we can write this in the mixed fraction, 5 2s are 10 plus 4 14. 2 4 by 5 is the value of tan theta plus 2 sec theta. 2 4 by 5. 2 4 upon 5. Given 5 cos A minus 12 sin A is equal to 0, evaluate sin A plus cos A, 2 sin A minus 2 cos A minus sin A. So let us shift this minus 12 sin A over here. So we get 5 cos A is equal to 12 sin A. Now let us bring this 12 over here. So 5 upon 12 is equal to sin A upon cos A, which is tan A. Which is tan A. Let us draw a right triangle where A is an acute angle. So this is A is an acute angle. So when we are given tan A is equal to 5 by 12, so this is 5x and this is 12x. So by Pythagoras theorem, we get this as 13x. 5, 12, 13 is a Pythagorean triplet. So let us now find sine A. So sine A is equal to opposite by hypotenuse, so which is 5 upon 13. And cos A is equal to adjacent by hypotenuse, that is 12 by 13. Now let us find the value of sine A. So put the values over here. So we have sine A is 5 upon 13 plus cos A is 12 upon 13 upon 2 cos A, that is 2 times 12 by 13 minus sin A, that is minus 5 upon 13. So 5 plus 12, this is 17 upon 13 upon 12 twos are 24 minus 5 upon 13. This 13 and 13 got cancelled. We get 24. 24 minus 5 is 19. So this is how we got the value of sin A plus cos A upon 2 cos A minus sin A as 17 upon 19. Given figure, angle C is 90 and D is the midpoint of AC. So you are asked to find tan CAB. So when tan CAB, that is this angle we are concerning when we are considering triangle ABC. So we have tan CAB. Let us do the first part. So tan CAB is equal to tan of CAB is opposite upon adjacent, that is BC upon AC. So BC upon AC. Now AC, this is tan CAB. Now divided by tan CDB. So tan CDB. So we will be considering this triangle. So wherein tan D is going to be opposite upon adjacent again, which is BC upon DC. So let us simplify this. We get BC upon AC into DC by BC. So this BC and BC got cancelled. Now, since this 2D is the midpoint over here, AC is 2DC. So we have DC upon, instead of AC, we can write AC is equal to 2DC. So we write here 2DC. So this is how we get this as 1 by 2. The first part we got answered as 1 by 2. Find tan ABC upon tan DBC. So we are concerned with this angle now. So when we are taking tan ABC, we are considering entire triangle ABC. So tan ABC again is opposite upon adjacent. So which is opposite is AC upon adjacent is BC. divided by tan DBC is opposite is DC and adjacent is BC. So this is AC upon BC multiplied by BC upon DC. BC and BC got cancelled. Again, AC is 2DC, so which we get it as 2DC upon DC. So this is how we got the value as 2. So this is 2. If 3 cos A is equal to 4 sin A, find the value of cos A, 3 cot square, 3 minus cot square A plus cosec square A. So 3 cos A, so what we will do is this 3 and this 4 will bring here 3 upon 4 is equal to sin A, and this cos A goes over here upon cos A. So sin A upon cos A is tan A. So we got tan A as 3 by 4. Let us draw a right triangle with A as an acute angle. This is A, B and C. So tan A is opposite by adjacent. So this is 3x, 4x. And by Pythagoras theorem, you will get this as 5x. 3, 4, 5 is a Pythagorean triplet. Now let us find first one, that is cos A. Cos A is adjacent by hypotenuse, which is 4 upon 5. And the second part will start over here, 3 cot square A. So for that, let us find the value of cot A. Cot A is going to be the reciprocal of tan, that is 4 by 3. And cosec is going to be the reciprocal of sine or cosec A. Let us write it here. Cot A is equal to 4 by 3. And cosec A is hypotenuse, that is 5 upon opposite, which is 3. So 5 by 3. Let us put the value 3 minus cot square A, that is 4 upon 3 and the square of that, plus cosec square A, that is plus 5 by 3 and then the square of that. So which is 3 minus 4 square is 16 upon 9 plus 25 upon 9. So which is 3, and for 25 minus 16 we get this as 9. So we get this as plus 9 upon 9, which is 3 plus 1, which is 4. Got it? Okay, so let us draw a right triangle where angle B is 90 degree. So this is angle B is 90 degree. Tan A, so this is A, this is C. Tan A is 0.75. So tan A is equal to 0.75, which is 75 by 100. Dividing by 25, 25 3s are 25 4s are, we got 3 by 4. Now tan A is opposite by adjacent, so this becomes 3x and this is 4x. By Pythagoras theorem, we will get this as AC as 5x. Now AC is given as 30. So you have AC is equal to 5x, which is equal to 30. So you get x is equal to 30 upon 5, that is 6. Then you are asked to find the length AB. So AB is equal to 4x, that is 4 times 6, which is 4 6 are 24 centimeter. Then you are asked to find BC. So BC is equal to 3x, that is 3 times 6, which is 18 centimeter. Easy that? In rhombus ABCD, the diagonals, okay, in rhombus ABCD, so you are given a rhombus ABCD. So let us draw a rhombus ABCD. In rhombus ABCD, the diagonals intersect each other at point O. So AC and BD intersect at point O. And we know that the diagonals of rhombus bisect at right angles. So you get 4 congruent right angles over here. Then you are given OB is 8 and cos ACAB. So when we are taking cos CAB, we are considering this angle. So cos CAB is equal to 0.6, which is 6 upon 10. That is 2 3s and 2 5s are 3 by 5. So cos is adjacent. So this becomes 3x and this is 5x. Okay, and then this is going to be, of course, 4x because 3, 4, 5 is Pythagorean triplet. So we get 4x is equal to 8. Then you are asked to find the length of the side. So let us find the length of the side. So length of the side is 5x. So first of all, since OB is given as 8 centimeters, so OB is 4x is equal to 8. You get x is equal to 8 upon 4, which is 2. Then the sides, that is AB is equal to 5x, that is 5 times 2, which is 10 centimeter. So all the sides of the rhombus, AB is equal to AD is equal to BC is equal to CD, all the sides we get as 10 centimeter. Now we are asked to find the length of the diagonals. So diagonal BD diagonal BD is equal to twice OB, that is 2 times 8, which is 16 centimeter. Then diagonal AC, if I have to find diagonal AC, it is 2 times AO. So AO, that is 2 times 3x. So it is equal to 2 times 3 and x is 2 here. 2 3s are 6 2s are. You get 12 centimeter is the length of the diagonal. So diagonals are 16 and 12, and all the sides of the rhombus are of length 10 centimeter. In triangle ABC, you are given AB is equal to AC is equal to 15. So this is your triangle ABC. One such question 5 we had solved in the same previous video. So this is 15 and this is 15 and BC is 18. Find cos B. So we need to have a right triangle. So we'll have AD perpendicular to BC, and in an isosceles triangle, this altitude is also a perpendicular bisector. So this becomes 9 and 9 over here. So you are asked to find cos B. So cos B is adjacent upon hypotenuse, that is 8 upon 15. So, sorry, not 8. This is 9. Adjacent is 9 upon 15. So 9, which is 3 3s and 3 5s. So we got this as 3 by 5. For finding sine C, we need opposite sides. So let us find AD now. So AD is equal to root of 15 square minus 9 square. That is square root of 225 minus 81. So which is 5 minus 1, 4. Okay, this is 144, which is 12 centimeter. So AD we got 12 centimeter. So this is how you get sine C, second part, that is sine C is equal to opposite, that is 12 upon hypotenuse, which is 15. 3 4s and 3 5s, we got this as 4 upon 5. Now tan square B minus sec square B plus 2. So tan B is equal to, let us write tan B. Tan B is adjacent, opposite by adjacent, that is 12 upon 9, which is 3 4s are 3 3s are 4 by 3. Sec B is uh, sec B is hypotenuse upon adjacent. So sec B is hypotenuse, which is 15 upon adjacent to B is 9. So 15 by 9 is 5 upon 3. So let us find the third part, which is tan square B minus sec square B plus 2. Let us put the value. B is 4 upon 3. So 4 upon 3 square of that minus sec square B, which is 5 upon 3, and then the square of that plus 2. 4 square is 16, 3 square is 9, minus 5 square is 25, 3 square is 9, plus 2. So 16 minus 25 is minus 9 upon 9 plus 2. Minus 9 by 9 is minus 1. Minus 1 plus 2, which will get as 1. So this is how tan square B minus sec square B plus 2, sec square B plus 2 is 1. Got it? The last question of today's video, in the triangle ABC, you have AD is perpendicular to BC. So you have triangle ABC where AD is perpendicular to BC. Then you are given sine B is 0.8. So sine B is equal to 0.8, which is 8 by 10. 2 4s and 2 5s. So sine B is opposite upon hypotenuse. So that is, this is 4x, this is 5x. Then this becomes 3x because 3 4 5 is a Pythagorean triplet. Now you are given BD is equal to 9. So BD is equal to 3x, that is equal to 9. So x is equal to 9 by 3, which is 3. Then you are asked to find AB. So AB is equal to 5x. AB is equal to 5x, which is 5 times 3, that is 15 centimeter. Then you are asked to find, we found AB. Then we are asked to find AD. So AD is equal to 4 times x, which is 4 times 3, that is 12 centimeter. And you are given tan C. Tan C is equal to, tan C is opposite upon adjacent, that is AD upon DC. which is equal to 1. But AD we have already calculated 12. So 12 upon DC is equal to 1. So you get DC is equal to 12 centimeter. Now you got this DC as 12 centimeter. This is 12. So let us find AC by Pythagoras theorem. So AC is equal to root of 12 square plus 12 square. That is root of 144 plus 144, which we can write it as 2 times 144. So square root of 144 is 12. So this becomes 12 root 2 centimeter. Got it? So children, we have completed with the second part. Coming up with the last part of the next 10 questions of this exercise. If you like the video, please share with your friends. And if you are new to the channel, please subscribe. Thank you for watching. Have a good day.